Hey everybody, this is leaning towards Module 4, Lesson 5, talking about exponents, and what we're going to talk about is leading towards order of operations, so that way we can solve longer and longer expressions working our way towards equations with algebra. So let's kick this off right here. First one, write each expression in exponential form. Well, how many 5s do we see here? This is all the same number. There are 1, 2, 3, 4, 5 5s. So we have our base, okay? In exponents, our base is the number we see over and over again. And since they're multiplied, okay, how many times do you see that? That's your exponent. So this will be 5 to what is known as the 5th power, because we have it out 5 times. Number 2 is the base of 2. There are 4 of them, so we have our base of 2, okay, and then our exponent will be 4. The way we set this up for exponents, we have our base number, whatever that value may be, with our exponent raised up here. So just a smaller number up in the top there. That's our main idea. So we're going for it. So 5 to the 5th power, 2 to the 4th power. So what's here is expanded form, and what we're talking about here is an exponential form to then go expanded. We talked about in class the other day about the accordion and how we stretch that out. So let's write each expression here in expanded form. Our base is 8 for number 3. If you look in your paper, example 3, okay, shows a base of 8. And how many times do we have that? Well, the little number right there, this guy right there, exponent of 3, means we're going to write that 3 times. So I have that 1, 2, and 3. And we can actually solve that, which we'll do in a moment. Okay, so then we also have 10 to the 6th power. This big number here, the base, all right, that base number is what we're going to write. And how many times will we? Well, the exponent tells us right here, it's a 6. So 10 times 10 times 10 times 10 times 10. And there are 6. And again, we can solve that too. There is a simpler way if you think of scientific notation. All right, think about base of 10, what we do when we multiply that. How many zeros are there? 5th one here, we have a letter. We don't have a number here, so we can express that as it's written. G times G times G. And the fact that we have 3 of those with an exponent of 3 shows us what our base is and our exponent 3 times. Can't quite get an answer for that yet unless we know the value of G. Okay, so our 6th example here was to go back with what we did before, okay, and actually in these is to solve it or evaluate it. So let's do that. I'm going to look at this one first. 2 to the 4th power would be 2 times 2. And you can use a calculator on these too, but I want you to see these written out. 2 times 2, okay, times 2 times 2. There are 4 of them. Notice this caret. There's no equal sign, so I'm not solving off to the side. I'm working my way down. So 2 times 2 is 4. Bring the rest of it down here, okay? 4 times 2 is 8. There's one more, so make sure you keep bringing these down. All right, with the rest of the problem. And then 8 times 2. 8 times 2 will give us an answer of 16. Okay, so you check with your calculator. Yes, please use a calculator. It's the easiest tool we can use for this. We get 16. So if we multiply 5 to the 5th power, and there are shortcuts on the calculators, I'll teach you guys those later, we'll have 3,125. And again, use the calculator to solve for these. Okay, that's the first 5. So then, we want to write this expression in expanded form. We can do this with decimals and fractions as well. As you can see, I had to move it up here. All right? Our base here, in parentheses, that means that's what our base is talking about. 3.8 or 3 8/10 raised to the 4th power. So this is equivalent to 3.8 times 3.8 times 3.8 times 3.8. And again, we can show these all in separate parentheses because we talked about different multiplication techniques. We can use parentheses to show that. 3 and 8 tenths times 3 and 8 tenths times 3 and 8 tenths times 3 and 8 tenths. And use your calculator and check what you get for an answer. Your answer will be this. 208 point something. I want you to figure out what the rest of it is. We'll check with that in class tomorrow. So make sure you solve it and use a calculator. 208 and something. Okay? So moving forward a little bit more, okay? For number 7, write the expression in exponential form and then evaluate. Same idea with decimals. We have a 2.1 multiplied by a 2.1. Our base is the same. It's the same value. And how many of them do we have? I see 1, I see 2, exponent of 2. Since we have decimals, it's nice to use parentheses to differentiate the values in the numbers with what goes where. Okay, we could be confused with 2 times 1 to the second power, but we don't want to do that. It's a decimal. We keep that number together grouped. Okay? So I'm going to go scroll up in a moment, but write the expression in exponential form and then evaluate for this one. 0.75 times 0.75 times 0.75. Okay, and what can we get? Because the base number can also be a fraction. We're going to show that in a moment. So again, 0.75. And how many do we have? I count 1, 2, and 3. So to the third power. Okay, so you fill that in, hold that there. Also, while you wait for about 10 seconds, solve these. Get these answers, because we're also going to show a fraction form as well. Okay? We can write these in fraction form. Why don't we do that first? Let's write in fraction form for here. So each one of these, what could we do? Okay? So I have 2 and 1/10. Let's look at this one. 0.75. 75 goes over the hundredths place, and we can simplify that fraction. This is equivalent to, well, how many quarters are in a dollar? 4. How many quarters make up 75 cents? 3 of them. Okay? So this, and what was our power? Or exponent. It's to the third power. So in parentheses, we can also write this. 3/4 to the third power. Multiply those out, you'll find that. Okay? Calculate those out. I'll be right back. So again, we want you to convert the decimals to fractions in examples 7 and 8, and then to evaluate those as well. Okay? Leave your answers as a fraction, though. All right, leave those as a fraction. I'll put a copy up on Google Classroom for you to look at as well. But then write the expression in exponential form, and then evaluate. So then evaluate. Write the expression here. I have 1/2 times 1/2 times 1/2. My base is the same. My base is 1/2. So in exponential form, how many times would we multiply that by? 3 times. Okay? The base is there. So write the expression in expanded form, and then evaluate. So for number 10, I have 2/3, and I have an exponent here. It's to the third power. So I'm going to write this same base 3 times and multiply. 3 times 2/3 times 2/3 times 2/3. Multiply like we did with fractions. Multiply across. You're going to do this with what you did before. 2 times 2 times 2. Multiply the numerators together, and what do we get? 2 and 4. I got 8. 3 times 3, which is 9, and 9 times 3, which is 27. Can we simplify this? Is it divisible by anything? Think back to what we talked about before. We're almost there. So back to number 6. We had the difference between g to the third and 3g. What's different about those two? What is different? They both have a 3. They both have a g, so what's different here? Well, g to the third power with an exponent of 3 is multiplying that 3 times. I've got g times g times g. And for 3g, instead, think about what is multiplication? It's repeated addition. G plus g plus g is 3 times. So the difference between this is we multiply g 3 times. The difference here is that we add g 3 times. Okay? So go through that, repeat this if you need to. Again, remember to smash a like on there, subscribe down to my channel so you can see all the other videos to go along throughout this year. Okay?